This is problem number 3 on packet 29. I am given the derivative of g of x is those three functions multiplied together, so x minus 2 squared times 3 minus x times x minus 5 to the third. So in order to find the roots of where g prime is equal to 0, those roots would be, of course, 2, 3, and 5. Now these points, as you know, are called critical points. And I'd like to remind you that critical points happen when the derivative equals 0 or when the derivative is undefined. Now, in our case, we have a polynomial function for the derivative, and so there's no place where it's undefined, but it's important to keep that in mind. So I've gone ahead and sketched out the beginning of a sign chart down here. Since this first term, x minus 2, is squared, that's always going to be positive, so it's not going to change our sign line whatsoever. So really all you have to think about is putting numbers into the last two terms. And once you do that, I believe that you get that the derivative is negative before 2, between 2 and 3, it's positive between 3 and 5, and then negative. So, of course, to finish out our sign line, we need to write that this is decreasing, it's decreasing again, then it's increasing, and then it's decreasing. So my function is going down again at 2, but I have a horizontal tangent right there, because the derivative does equal 0 there. And then it's going to go up, and then it's going to go back down. So I'm not given any initial points, so this sketch is going to be a little bit arbitrary. But I do know that I have a horizontal tangent at 2, I have a horizontal tangent at 3, and I have a horizontal tangent at 5. Now, so my function's coming down, it's decreasing until it gets to 2, but there's a horizontal tangent, and then it continues to decrease. So my guess is that there's a change in concavity there, and the function then increases after 3 up until it gets to 5, at which point it switches direction again and goes down.